Next series of problems had four equations. They appeared to be linear, and you were asked to solve for x. In the first one, if I take away an x from each side, right, you'll remember that this leaves 3 x's on the left-hand side plus 1, and that equals -5. And I could subtract a 1 from each side. Again, the mechanics, if you're subtracting the same thing from both sides of an equation, you're good to go. Adding the same thing, multiplying, dividing by non-zeros. This ends up being 3x is -6, and when I divide by 3, we get that x has to be either -6 over 3 or x is -2. So x is -2, and when I do plug that in, it's important to note, when I plug in -2 here, that's 4 times -2 is -8. -8 plus 1 is -7. And on the other side, when I plug in -2, I've got -2 minus 5, which is also -7. Remember, this is not a solution, right, unless it makes this truly equal. And you can see the value x is -2 does make it equal. So I often like to plug in values like that and verify my solution. Let's look at B. Real quick application of the distributive property. This becomes 10x plus 6. Some of you did not distribute this to the 3. I noticed that in a couple groups. You didn't have this 6. On the other side, we have got 6x minus 3. I'm going to take away 6 times x from each side. On the left-hand side, there's 4 x's left over, plus 6, and that's -3. If I subtract 6 from each side, we get that 4x is -9. And then my favorite answer, please just divide both sides by 4. We get that x is -9/4. This is the preferred answer. A lot of you, worked hard to put it into a decimal or a mixed number. Just leave it as this improper fraction. -9/4 is fabulous. Let's see. Question C. Application of the distributive property. This would be 6 times x minus 3 plus 5 equals, I can combine the 4 x's and 2 x's and write there's 6 times x plus 2. I notice each side has 6 times x, so I'm going to subtract that from each side. When I do that, I'm left with -3 plus 5, which would be 2, and on the other side I've got just the number 2. So this turns out to be an identity. The left and the right hand side are actually just different ways of writing the same expression, same linear expression. So it turns out it doesn't matter what I pick for x. I could pick anything for x, plug it into the original equation, it would always force the left and right hand side to be equal. So on this way, when we just say the solution's all real numbers. And then finally for D, I've got the 2x plus 5, an application of the distributive property again. We've got 4x plus 14 minus 2x. 4x minus 2x is going to be 2x on this side, so 2x plus 14 over here. On this side we've got 2x plus 5. I'm going to again take away 2x from each side, and I get this expression. 5 is the same thing as 14, which is clearly a contradiction, right? 5 and 14 are not the same. And when we see a contradiction like this, and I would encourage you to look at your steps and make sure that there's not an error. But if you don't see an error and you can really see, yeah, my variables are really canceling on both sides, and I've got numbers that are not equal to each other, this is a contradiction, this is clearly not true, we would write down that there's no solution. I don't care what you pick for x, it's not going to be the case that you can make 5 and 14 be the same thing.